I personally believe that we need to be careful with general purpose AI technology. It's not so much because we might lose control over this technology, although that is a legitimate concern that some of the world's leading AI researchers have repeatedly called attention to, right? Let's imagine for a moment we get all of this under control, right? That sooner or later we get past the stage where the systems we build automatically tend to be buggy and unreliable, and where really we can automate everything. Should we want this? I mean, what do we then do? You and I and people in general. So some enthusiasts say, well, then we have, 16 waking hours in the day to do creative things. But if any creative thing you attempt can immediately be replicated or has already been anticipated by some machine intelligence or can be improved upon, that's not a very satisfactory point of view, right? I think my hope is that within the next 10 years, we will focus a little bit more on safe and secure and sustainable AI systems that we can rely on, whose strengths and weaknesses we know well enough that we can responsibly use them in order to run our societies in a better way.
Thank you for joining Once Changing the World, India's first Future Tech Meets Sustainability podcast. I'm your host, Eddie Avil, and today I'm delighted and honored to have with me Mr. Holger who's an Alexander von Humboldt Professor of Artificial Intelligence and Director of the AI Center at RWTH Aachen University, a Professor of Machine Learning, University of Leiden, Adjunct Professor of Computer Science at the University of British Columbia, Canada, Chair of the Board, Confederation of Laboratories for AI Research in Europe, Vice President, European Association for Artificial Intelligence, and his research is aimed at methodological and technological advances in human-centered AI for good, and AI for all. So, Professor, really appreciate you taking time and being part of the podcast. Wanted to start with OpenAI and ChatGPT. For me, I think it's one of those coolest moments in human history because, till that point in time, I think AI was doing its ups and down cycle, the boom and bust cycles. But the 22 November, I think, it kind of democratized AI. And then obviously, everybody kind of joined in forces. When it first kind of launched, it was pretty much magical. Then Ilya Sutskever kind of, tweeted that it's got these emergent properties and has like maybe some kind of consciousness, and then there was like the net kind of blew out. What's your thought on chat gpt, and what do you think about its growth from 22 till now, and specifically if it'll be great if you could address the latest launch, the chat GPT-5, because the assumption was possibly maybe we could, through these statisticals data and data out model, we could possibly maybe reach or go towards artificial general intelligence, because some of the top AI research, be it Demis Hassabis from DeepMind, Sam Altman, Ilya Sutskever, and many others, really believed in the scaling hypothesis. But that seems to have that seems to be a blocker. So, your thoughts on ChatGPT and specifically GPT-5 launch and the scaling hypothesis?
Yeah, I'm very happy to be here, and of course, happy to share my thoughts on these topics as somebody who's been involved in AI research for, I guess, the past 30 years. Doesn't feel like it, but really has been 30 years now. So, first of all, the chat GPT moment that you alluded to a few years ago, and I really think that that was something significant. First of all, beyond any doubt, there have been great technological achievements that have enabled the broad use of AI systems such as ChatGPT. I don't think this really is limited to ChatGPT. And also, I think the technology that we should be excited about is not limited to generative AI or large language models, but they do play a very important role. And I think the most important role this kind of technology actually plays is in showing to the world, showing to everyone that AI systems can do meaningful, interesting things, right? Which, to be very honest with you, they could do before 2022, but that was only known and in some sense directly relevant to specialists, right? And Although in some sense, these developments have been affecting people broadly for longer than they are aware of. I think having that global awareness that AI technology can do some pretty amazing things is something new, right? And also something exciting and in some sense useful, comes also with a bunch of risks. I'm sure we can talk about that later. So then about ChatGPT, so GPT-5 and the latest version of ChatGPT that makes that available. To be very honest with you, I think for most of us that's a bit of a disappointment. And the reason for that is that some of the major shortcomings and limitations that have been there before are still there, right? So I've recently seen a very interesting LinkedIn post on somebody asking for something relatively simple, which was, give me a poster of the US presidents, a few, maybe 150 years back, with their dates of office and their names and pictures. And what came out was horrendously wrong, right? And I think that in a nutshell shows what the problem is, right? There is still a major problem that these systems, including GPT-5, make up information. They give incorrect information, and they do that in circumstances that are not well understood. In other words, nobody can really predict what kind of queries will result in grossly incorrect or slightly misleading information, and which ones will result in correct information. And that's disturbing, right? I mean, that sort of also limits the usefulness of these systems. It doesn't make them useless, but it means that we have to use them with great caution. And so GPT-5, I think many people believe that this would be a major step towards avoiding these sort of issues, overcoming these kind of issues. And it looks very much like this hasn't worked out to the extent that the enthusiasts were hoping. Um, Personally, I'm not surprised at all about this because, like many of my colleagues with a bit of insight into the underlying technology, I believe that the underlying technology has serious limitations, and that scaling, you alluded earlier to the scaling hypothesis, which kind of says, if we just have more data, more compute, and larger models, eventually we will get to full scale human level intelligence. I believe that scaling hypothesis is quite wrong. We can still make further progress, and I don't doubt that GPT-5 is better in some measurable sense than previous versions of the LLMs trained by OpenAI. But I think we are sort of reaching a limit where with, probably arbitrary amounts of new data and scaling, we will not solve some of these fundamental problems. So we need new and fresh ideas if we really want to get to AGI, to artificial general intelligence. But before we even discuss this, I think the question ought to be asked, do we even want AGI, right? Is that even a desirable goal to pursue? And here I think one can very legitimately have different opinions. I mean, we know what, the leaders of the big tech companies have to say about that. Almost unanimously, they go like, well, first of all, it's inevitable. And secondly, it's a great, great thing for humanity. And I think those statements have to be questions. Is it really a great, great thing for humanity? And is it something that we should treat as inevitable?
Right, right. So, Professor, I mean, so many interesting pieces you mentioned, about the AI risk, the model hallucinating, and then you are not surprised about the latest ChatGPT's performance. And do we actually need AI? That's such an interesting question because I think today the world is racing towards maybe the large nations and these big tech companies are racing towards acquiring these technologies because at the bottom they kind of fundamentally understand that acquiring these technologies will give them some kind of an undue advantage. And I think we live in a capitalistic world and a centralized world throughout. I think the nature of the world has been that the powers that we obviously understand the divide and rule, and so it's been like a central, maybe whether it's a nation or a big tech company, they understand that, and I guess that's what they're doing. And obviously, that narrative about the AGI, I'm not so very sure whether the question of like do we actually want AI? Because, Professor, I guess inherently we humans are curious, and I think there will be much more things beyond AGI itself because we constantly keep on creating. So I don't think AGI is the pinnacle because there's quantum computing, which is kind of we kind of tinkering around. Maybe we'll understand the source code alive because here we are like tinkering around binary codes, and with quantum computing you'll be kind of tinkering out with the source code alive in the atoms, and what would that mean? So I mean, so I'm sure like every step that we take, it happens because of these brave thinkers such as yourself who are constantly kind of pushing the paradigm and building things which maybe might, obviously philosophically we might need to question whether we need it, but I think it's never going to stop because we are always creating. We are curious creatures, and we'll always keep on building. Is what I kind of believe. I would love to kind of start with maybe you explaining your work on stochastic local search algorithm and its role in enabling the creation of the work that you pioneered, auto machine learning.
So let's start a little bit with automated machine learning, which is indeed something that my group first at UBC, together with colleagues there, and then at Leiden and now at RWTH Aachen, have been quite become quite well known for, and I think it's useful and interesting work. So what is AutoML? If you want to effectively design and deploy machine learning applications, this is a very broad term, right? And it includes, of course, things like the LLM-based systems that we were talking about a moment ago, but also much simpler systems, such as, a little pattern recognition algorithm that runs on some embedded device, right? Or a little regression algorithm that allows us to predict when some piece of machinery will fail or will need servicing. So we don't have to think full on large language models in order to see useful applications of machine learning. But the point is, in order to design useful machine learning applications, it currently still takes a lot of expertise, right? We'll get to the question whether you can do it simply by prompting a large language model in a bit, right? But traditionally, and I believe that's still very much to be the case, in order to build a good machine learning model and then deploy it in a responsible and effective, also economically effective way, requires quite a bit of knowledge and expertise, right? So I would say for the more sophisticated tasks, it requires PhD level expertise in machine learning, right? Which is, by the way, also why some of these machine learning experts are extremely well paid, right? Because there isn't that many of them, and there is an extremely high demand for that specific expertise. So given that sort of bottleneck in expertise and talent, it's, of course, a very interesting thought to try and automate some of the decisions that these machine learning experts have to make when building systems, right? And that includes decisions about the training process, about pre-processing training data, but also about the model architectures if we think of neural networks themselves, right? So how many layers and so on. And it turns out that the process of making these decisions can at the very least be partially automated, which allows the people who basically are carrying out this process to be more efficient and to basically just do more of it with their time. It also lowers a little bit the level of expertise that's needed in order to do this kind of work. So in other words, you maybe don't need to be a PhD level expert for some of these tasks, but you can be good enough with a master's or bachelor's level expertise, right? So that's the key idea behind automated machine learning. And the way you do that is that you basically cleverly combine techniques from machine learning, from statistics, and from optimization, right? A lot of machine learning behind the scenes is optimization anyway. And this is where my previous work from many years ago on stochastic local search comes into play, and stochastic search in general, because it turns out that there is this broad class of optimization techniques known as stochastic search. So these are techniques that can basically find good solutions within really huge spaces of possible solutions. And they do that by cleverly using randomness. And so now you might wonder, why do we have to throw dice? Why do we have to use randomness here? And the reason is that unless you have basically perfect knowledge about how to get to what you're searching, it's a very good idea to have a bit of random exploration in there, and it needs to be the right amount. Now, if you calibrate sort of the targeted searching for good solutions, because you kind of know what they look like, right? Machine learning models that are particularly accurate, for example, that don't need a lot of training data, that don't need a lot of energy, right? If you combine that sort of targeted searching with a bit of random exploration and you calibrate this very well, then you get systems that perform amazingly well. And in this case, what you get is systems that allow you to automatically find machine learning architectures and the hyperparameters, the little dials and knobs that you have to twiddle in order to get good performance out of them, in order to really, really make them shine and work well. So in a nutshell, that's the significance of automated ML and the role of really powerful optimization techniques inside AutoML.
Right. Now, how interesting is that, Professor? So I've been invested in XR technology. We've been building, immersive technology. And the reason I'm mentioning that is because there's this interesting person called Kichi Matsuda. He's created this very interesting video called AI Agents, where he shows a future where, the world is going to move from carrying technology to wearing technology, because right now we are kind of stuck to a 2D interface, and then you will have these head-mounted wearable devices, and these head-mounted wearable devices will be intelligent. So he's shown this world where people are actually wearing these glasses, and they have multitudes of agents. And you converse with the agents, and it's basically a future where everything is natural voice interaction. You speak and you build things. You build images, videos, edit things out, possibly large language models. And so you spoke about, can we get to that world where we democratize things enough where maybe we could, automate the entire pipeline and build a large language model just out of prompt? That's very, very interesting. Will be great if you could, talk about that. And since maybe we spoke about automation, these large language models, largely they are black boxes, and that's something that, obviously there are these people working on mechanistic interpretability and, understanding these AI models, what they're doing. Do you kind of, think of fear that, the more automation that you kind of, you more automate these models, eventually these could become like, more, black box where we don't kind of understand things?
Yes. So that really is an excellent question, right? The more we automate, is it the case that the less we understand what's actually happening? And if so, is that a bad thing, right? And so, first of all, let me say that I think it's true. The more we automate, the less we understand what's going on inside and under the hood, right? Now, many of us believe that's not necessarily a problem, right? I mean, I guess you and I might have a pretty good idea how something like, a computer monitor works, or maybe even a CPU or a GPU, which are the processing chips inside a computer. And maybe we have a rough idea how a modern car works, right? Although I guess neither you nor I could build one. We still drive them and it's fine, right? So in other words, we can use technology that we don't understand. And that's the case for most of the technology that most people use every day. Is that a problem? And I think the answer is it's not necessarily a problem, but there are certain things about the technology that are very important to understand. And I think cars are a good example for that, right? I mean, we're perfectly fine with not understanding in detail how a car works. I bet most people don't even know that. Let's not speak about, autonomous driving or any futuristic cars, just the ones that are on the road right now in India, in Europe, in the Americas, right? Most of these cars actually are chock full of computers, right? Of small processing units that do all sorts of very sophisticated things without any driver being aware of it, right? And this has nothing to do with autonomous driving. It has just to do with, managing the engine and, managing stupid things like the air temperature inside the cabin and things like this, right? So cars are amazingly complex machines that we just take for granted, and we drive with, maybe a few weeks of instruction. Any 16, 17, 18-year-old can reasonably safely drive a car. So why would we need to understand more about them? And the reason is quite simple. We can do this because the cars have been engineered so that their strengths and weaknesses are very well understood, right? And we understand extremely well, engineers understand extremely well under what conditions a car becomes dangerous, right? And then we have traffic rules that make sure that these conditions don't arise all too often, right? So I give you an example. We know perfectly well that with the kind of cars that we have right now, driving at 200 kilometers an hour through, a heavily populated area with kids playing and so on is completely irresponsible. And the reason is because you can stop in time if anything rather predictable happens, like, some kid jumping in front of the car, and it's a disaster, right? So we know that very well because of the way that cars are made, right? And because of the way the physics of cars work. Um, I think when we talk about complex AI systems such as large language models, ChatGPT, and so on, we don't actually know when they start failing us, right? So this is more of a trial and error kind of thing. And that is the kind of black box nature that we have to be worried about. Technology that, seems to be perfectly fine cruising along at 200 kilometers an hour one moment and then drastically fail us, which has happened, not with GPT-5, I think, quite yet, because that's still very new, but with previous versions of these large language models. I give you an example. There has recently been an item that made the news where some startup used a large language model for coding, right? For, accelerating the process of developing some software, and that software was interacting with the company's database. So what happened is that, one of these so-called vibe coding sessions that was supposed to result more quickly in, new software that then would make the company work more efficient, actually erased the entire database. A database with invaluable information about the company's customers and products and whatnot, right? Which was a complete disaster. And why did that happen? Well, it happened because the code that the AI system produced was not safe, right? And then actually, very interestingly, the AI model, it apologized profusely. I mean, they're pretty good at with language. It apologized profusely, but basically said there's nothing that can be done now. This database is lost, right? So with any employee that would do such a thing, you would fire the employee, and probably you would have never hired the person, because it's not so difficult for us to ascertain that, a human software engineer has the necessary skills for something like this not to happen. But we cannot really do this with large language models yet. So we don't know when they will do drastic things like the example that I've just explained. And therefore, it is quite unsafe to use them for purposes such as programming, as soon as the software that comes out is used for anything that has effects in the world, right? Beyond just amuse us, for example. So we have to be very careful. And so that is the way in which the black box nature of high levels of automation can come and get us and cause a lot of damage. Not because we don't understand in great detail what's happening inside, but because we don't understand the strengths and weaknesses of the technology. We don't understand the conditions under which it can provide value and the conditions under which it will fail us. Now, I'm as excited as you are about a future in which AI plays a major role. And there's basically two reasons for that. I think, our world is facing pretty enormous challenges. And some of these challenges are shared globally, right? One of those is climate change, right? If you follow the news, you see, reports of the kind of heat waves and forest fires and things like this that really speak a very clear language as to the detrimental effect of the climate heating up, right? And it's not easy to actually counteract this, right? It's not easy for science. It's not easy for policy. It's not easy for citizens around the world to do what needs to be done. I think actually clever use of AI can, for example, help us live the kind of lives we want to live while consuming less energy by making processes more efficient. And that's incredibly important, right? Because few people are willing to give up standard of living, right? But I think people will be quite willing to trade sort of more technological modes of living, modes of transportation, for example, ways of heating in the winter and cooling in the summer when it's too hot, and therefore do the right thing if it becomes affordable to do that. And AI is one of the technologies that can help us make affordable and effective new technology to help us avoid the very worst of climate change, right? And that's just one example. In Europe, we have another problem that we're very concerned with. I don't think you have it quite as much in India yet, but that might also come in the future. And that is demographic change. That is basically the prospect of a shrinking workforce. And what happens when basically the workforce shrinks is that if you want to keep up your quality of life, the fewer people that do the work, they need to be more effective. And once again, automation and AI technology in particular can greatly help with that process. So two examples there of why we should be excited about, more capable AI systems in the future. But I'd like to point out that for neither of those two positive kinds of effects to be there, do we need AGI? Do we need artificial general intelligence? So for all of this, sort of narrow AI systems might be just fine. And for narrow AI systems, of course, it's easier to understand under what circumstances they work well and they don't work so well, right? For AGI, this is incredibly difficult, as it is actually for human beings.
Right, Professor. Yes, I think AI, even narrow AI, is actually changing the world in ways which is like really, really awesome. And environment, I guess, it's a huge problem. I think just maybe a week, 10 days back, there was a cloud burst here in India and Uttarakhand. And there was lots of life loss. But I guess that's happening because we humans are kind of not understanding that the consumption without conservation is going to lead to a problem. We are continuously consuming, and because the world has become economically empowered, we are not understanding these ACs, these cars, these flights, and so on and so forth is adding to a carbon footprint. I think there needs to be more conversations and where we understand that we are actually literally killing the world that we live in. And you spoke about the shrinking workforce. Yes, I think maybe India does not have the problem, but yes, I think globally that seems to be like a huge problem. Japan, Europe, and I guess that's the reason I think there's a lot of workforce from India, from China, moving out to places such as Europe and India. You spoke about AI coding. Yes, there's this, that you cannot completely latch on to these coding agents, but there's a lot of people who are actually using AI for coding. These coding tools, we per se, our organization also uses it. Google, Sundar Pichai came out and mentioned that they are leveraging like a certain number of AI to kind of do their coding. You are someone who's like proponent of using automation, more and more automation. What's your intuit on these AI agents or the future of coding? Because people talk about AI coding agents, AI co-scientists, and so on and so forth. But these agents at this point in time do not have like persistent memory, neither do they have reasoning complete skills or plan it, or are able to plan and act. When do you think we should have all of these things binding together, and maybe possibly we could have tools, automated tools or agents which could be your AI co-scientist or coding tools?
Yeah, that's very difficult to predict because I think that's exactly one of the things we will never get just through scaling the technology that's currently underlying LLMs, right? So one thing I always find interesting to note is that it's actually quite well known that the main reason why Microsoft got interested in OpenAI and their technologies was not so much because of the chatbot applications like ChatGPT, but to automate workflows and coding, right? So Microsoft very smartly saw that there's a major bottleneck there, right? I mean, software has become incredibly complex. So it's difficult for even very good software engineers to manage, right? And that's also, by the way, one of the reasons why a lot of the software that we have is somewhat buggy and actually quite often unsafe. And then also reasonably inefficient, right? So these are three issues that with human generated software um, tend to be major issues, right? Now, it turns out that the approach to coding that basically tries to leverage the technology that got us pretty far with natural language is, at least in my opinion, completely wrong. And why is that? Well, computer code might sort of superficially resemble natural language, but it's anything but that. Computer code is essentially operationalized mathematics, right? And so in order to make sure that computer code is correct and safe and efficient, what you need is mathematical, logical thinking. And that is one of the reasons, right? As you know, I work at a university. I teach young people, amongst other things, programming and thinking about algorithms, right? And so it's incredibly difficult to get humans to the level where they don't just think about this in their sort of everyday mode, right, with natural language. Because as long as you think about coding in natural language, you will not be efficient, you will not be good, you will not write correct code. So you have to teach these young people logic first, which doesn't come easy to us because we're not logical beings, right? I mean, you know about Star Trek and Mr. Spock, right? There's a very good reason why, one of our sort of prime representations of something otherworldly is sort of, somebody who operates and lives in logic, because we don't do that, right? That's not our natural state and strength. So the problem is that the technology that allows us to be very good with human language, right, these large language models, is completely unsuitable to deal with logic. And that is why it's not surprising that large language models, that ChatGPT, even after GPT-5 is now under the hood, cannot think logically, reason logically, solve even relatively simple logic puzzles, right? And that's also the reason why this technology cannot be used to responsibly generate computer code without a lot of expert oversight, right? Now, I don't dispute at all that in the right hands, meaning in the hands of people that actually can build algorithms, that can understand computer code, right? These tools can be very effective in helping these people, these human experts, to be more efficient. No doubt about that whatsoever, although I would point out that scientific studies on the subject don't consistently show huge efficiency gains yet, but I do think there's efficiency gains to be had. There's also no doubt that AI techniques in general, and now I'm not speaking just of, large language models and ChatGPT and so on, but AI techniques broadly speaking can be enormously useful at logic-based tasks such as coding and planning and scheduling, right? But it's not the kind of AI that's underlying ChatGPT. It's a different kind of AI that lives a little bit more in the shadows, right? The experts know about this. Actually, there are excellent AI scientists of Indian descent that in the United States have been working on these sort of automated planning algorithms for years and years, right? And made major, major progress. And this stuff has industrial applications as well. But it's mostly used by experts, right? Not by pretty much anyone like ChatGPT. And that's why not so many people know about it. But this is useful, this is powerful, and this has made a lot of progress over the last, let's say, 20, 30 years. And what I think will be happening is that sooner or later, this sort of natural language interface to computer systems will become quite good. But then under the hood, there will be other types of AI systems, for instance, reasoning AI systems that will do certain parts of the work, such as coding, such as mathematical proofs, such as logically thinking about science. And when we manage to do that, then I think we can have systems that can be used effectively and also responsibly for the kind of tasks that people are trying to use, ChatGPT and similar systems for right now. But I don't think we're anywhere close to that. That requires a sort of integration between different AI techniques that none of the experts, at least that I know, has a really good idea how it will be achieved. So who knows how long it's going to take until we get there.
Right. Yeah. So I think, Professor, I mean, we're sitting in such an interesting point of time. Earlier, most of the breakthrough innovations would come out only out of US or maybe, Europe. But I think the world has completely changed. And this has happened largely because of the democratization and access of knowledge, because of, the internet itself. Though that the world, I believe, is like, with the herd mentality only working towards large language models, there are so many other areas, where people are working at the cutting edge. There are people who are working at brain inspired approaches, building neuromorphic computing, focusing on mimicking the brain's hardware with spiky neural network. Then there are companies who are trying to reverse engineer an animal's brain. There's MIT startup which comes to my mind, Liquid AI, who's working on it. Then there's Dr. Fei Li, who's advocating building rich world models through these self-supervised learning like JEPA, or by grounding these world models in physical spatial world, because that's Dr. Fei Li believes that these spatial worlds with embodiment, of course, will kind of bring you towards this thing. And then there are people like Ben Kurtzel and others who are working on neurosymbolic AI. So there are these so many people working at the cutting edge of research, trying to kind of probe and possibly build maybe things which could have more general purpose in intelligence? What are your thoughts, or what are your intuit on that? And according to you, who are amongst the leaders in the space, maybe asking the right questions, or possibly closest to maybe you know uh, tapping on and kind of understanding, and maybe laying the foundation layer of maybe a machine which truly has general purpose understanding?
That's extremely difficult to answer, right? I'm part of the AAAI, so this is sort of the biggest international organization of AI scientists, the Association for the Advancement of AI. So I'm a member of the presidential advisory panel of AAAI that has released earlier this year a report on the future of AI. That is actually a document that can be found online, might be interesting to your audience as well, because it's targeted not just to AI researchers and scientists, but to a good part to a general public, right? And so the question is, where are we and where are things going? And so I really hesitate to, name specific people who I think will make breakthroughs. I do think amongst those that, have a lot of credibility in AI and are, publicly very outspoken about things. Jan LeCun is quite right in being skeptical about the scaling hypothesis and quite right about his emphasis on something else being needed. That said, I don't think he has found yet what is needed there, right? And many of my colleagues, as you say, are really working on that. But let me get back to the question for a moment. Should we really race towards AGI? And I think you said something interesting earlier in our conversation, which is, humans are curious. So of course we have this innate desire to build things and understand things and do amazing things. That's all quite accurate. But I don't think we do this, completely without trying to think about the consequences. And one area in which this is certainly the case is the area of genetic engineering. As you know, internationally, there have been restraints on this, right? There are certain things that might be scientifically possible that are just not done, not in any highly developed country in the world, although they might be possible. One of them is cloning humans, right? It's not done. And it's not done for very good reasons. And also gene editing of humans is severely restricted. And again, for very, very good ethical reasons. I personally believe that we need to be careful with general purpose AI technology as well, in a similar way. And why is that? It's not so much because we might lose control over this technology, although that is a legitimate concern that some of the world's leading AI researchers have repeatedly called attention to, right? But I think the bigger problem is that on the path towards such technology, it's almost inevitable that we have weaker forms of AI, including what we have right now, that can cause incredible damage if they're used in an irresponsible way. Let me rephrase, that can cause incredible damage if they're used in anything but a very carefully thought out and responsible way. And I think what we are currently seeing is not quite that. It's not quite a carefully reflected and responsible way of developing and using AI technology. And I really believe that must change. I think if this doesn't change, what will happen is that the human curiosity and energy to try out things, which usually is a good thing, I agree with you, will get us very quickly into a world in which we drown in incorrect, in buggy, in unsafe, and hardly usable software. And I don't think if you take into account how much of our modern societies is already run by software, right? From the electrical utilities through, public transportation, through the global financial system. So, medical, a lot of it is used in the medical domain, right? Hardly any hospital that could work without their IT systems working essentially flawlessly, right? So now imagine a world in which all of this software is replaced by software that 95% of the time is more capable and 5% of the time just fails miserably. Honestly, Eddie, I think that would be a terrible world to live in. I think that would be a disastrous world to live in. But I think it's the world that we're headed towards if we, single-mindedly pursue this, I would call it a pipe dream of AGI by scaling up what we currently have. We need to step back and be a little bit more careful about what we're doing. And then I think we can reap great rewards. So for example, I believe that the future of medicine is, really driven by AI. But I don't think the future of medicine is driven by scaled up versions of large language models. I don't believe that at all, not for one moment. I think the future of medicine is driven by a broad set of AI techniques, some of which are already used, for instance, for analyzing medical images, but a broad set of AI techniques whose strengths and weaknesses are well understood and that work well together in tandem with human practitioners, with medical doctors. I think that is the future we ought to be caring about and building right now. Um, in addition, I don't think, let's imagine for a world, for a moment, we get all of this under control, right? That sooner or later we get past the stage where the systems we build automatically tend to be buggy and unreliable, and where really we can automate everything. Should we want this? I mean, what do we then do? You and I and people in general. So some enthusiasts say, well, then we have, 16 waking hours in the day to do creative things. But if any creative thing you attempt can immediately be replicated or has already been anticipated by some machine intelligence or can be improved upon, that's not a very satisfactory point of view, right? And if, 95% of the art that's being produced is produced by AI systems, I mean, what kind of a world is that really? There's a ton of good psychological research, some of it dating back 30, 40 years, but some of it also quite recent, that shows that people in general take a lot of the meaning of their life and happiness out of, their work. Rather surprisingly, their work is very important. If you take that away from people, I'm not sure that you make them happier. I don't think the world in which, AI provides all the value, the world that Elon Musk, for instance, sometimes talks about, right? A world in which machines do everything for us and we basically just have a universal income and then consume and are on perpetual holidays. I don't think that's a world in which most people would be happy. So I think what we need to do is focus on a world in which, yes, we use machine intelligence and machines in order to get certain important things done better. We should also carve out some areas where we say, well, maybe these are predominantly human occupations, in particular creative areas, right? Because they give people meaning, people are actually pretty good at, and we don't want to replace this, right? And then we build machines and AI systems that work well together with people rather than ones that replace people wholesale. And that, of course, is the idea behind human-centered AI, which, as you know, is what in Europe officially we are striving for and towards. And I think that's a good thing.
I think that's a great thing, Professor. And I hope that the conversation globally veers towards that. But unfortunately, I think, some of the largest investors, they run the world and they are the ones who are pushing the narrative behind, the AGI and AGI hype. And also this global race of sorts, because I think nations forever want to kind of lead, because they understand that, acquiring a certain technology stack will give them an undue advantage. And you rightfully pointed out, I mean, we are sitting at an existential risk at sorts if we don't kind of really carefully look into this, where we make machines that are truly safe. We're sitting at the cusp of genetic editing. In fact, I had a conversation with Andrew Hassel just a couple of weeks back, and Andrew Hassel is a great mind. He's talking about like kind of maybe doing the first human cloning. I mean, do we actually need that? Obviously that is a question. You spoke about AI for science. I mean, there's AlphaFold and there's somebody who's a team which is building a virtual cell. I think maybe we do that, the world will completely change, because there are billions in this people who are like suffering because of healthcare, and through AI, maybe we could solve that, and maybe finally go towards maybe finding a cure. Because largely I think a pharma industry is maybe just like treating them, not curing them. And possibly maybe with AI, maybe we'll go towards a world where we'll actually be curing these people. Wanted to get your thoughts on Claire and European AI, because there are some great startups from Europe itself who are kind of working at the cutting edge of AI. One being DeepMind, though they are like funded by a US conglomerate. Then there's Mistral, again they're funded by US folks. But are there other hidden champions that like academia or startup that you're talking about? And would also be awesome if you could talk about how Claire and Europe AI is playing a role in helping these startups transition from academic projects to world contending players.
Yeah, so that's a very interesting question. So I think there are quite a few hidden champions in Europe. So let me mention two from Germany, actually three from Germany. I would say, not so much because I'm there now, but because the ones that people mostly hear about these days tend to be from other European countries. You've already mentioned DeepMind, Mistral, Silo AI would be another one that could be mentioned, right? But there's these three from Germany that I think for various reasons are quite interesting. So the first of them is called DeepL. And DeepL is a company that is still, as far as I know, 100% owned by European investors, including, of course, the people who founded the company. That is basically specializing on machine translation. So you might wonder, how is there even business in this? But it turns out that they started being as good and better than Google just before the big LLM sort of breakthrough happened, right? And now they are still basically as good and better as ChatGPT. And they're as good as or better, despite the fact that they're much smaller and that they have much less data. But they discovered an important secret. Actually, it's not so much of a secret, but they sort of cleverly leverage that insight. And that is, it doesn't necessarily matter how much data you have. What matters much more is that the quality of that data is very high, right? And so exploiting that, they've managed to build one of the best translation systems that there is. And, I always tell people around here, use this for whatever translation jobs that you have, unless you have really good reasons to use other technology instead. Also quite important in that context, as you said earlier, it's not a good idea to engage in kinds of behaviors that have a large CO2 footprint or energy footprint, because we have that big problem in the world, right? Well, one of these behaviors is to use large language models for tasks for which they're not really suited, or for which there is other technology with a much smaller energy footprint that's much better. So before speaking about the other two companies, what I'd like to say is that, if you have two different kind of software services for a very specific thing, such as translating language or searching the web, and one of them uses 10 times as much energy than the other, it's very clear what the responsible thing to do is, right? So you don't necessarily have to be better in terms of the quality of the result. It's also a great progress if you can do it with less resources. And that is a very important niche, and companies such as DeepL show us how to do this, right? And I think that is also sort of European strengths, to get excellent quality with less resources, because in the history of Europe, we've learned pretty much the hard way what happens if we are not careful with our resources. I mean, that's one of the reasons why in Greece, for example, where there used to be huge forests, which have been cut down in antique times already, right, in order to build wooden ships. Now you see the consequences of this, major shoreline erosion, climate that isn't the way it should be, and so on, right? So people in Europe have faced these realities for much longer than people in North America, for example. So the two other companies I want to briefly mention, one is Celonis, and they're actually engaged in process intelligence. And this is something very interesting and important. It's basically a kind of AI that helps businesses and companies, including companies that produce things in large factories, to better understand bottlenecks and problems in their processes and then fix them. And you might imagine that this is incredibly important in order for the companies all over the world to become more efficient, both in terms of energy, but also in terms of economic efficiency, right? And actually, they have customers already around the world, including a lot of the S&P 500 companies in the United States. So this is no longer sort of a small startup. This is really something that's already quite big, with a market capitalization of I think in the tens of millions. So that's another really good example. And then there's Aleph Alpha, which is basically doing generative AI. I'm sure you've heard of them, because they're sort of in certain areas in direct competition with Mistral and OpenAI and so on. Of course, they've gotten a lot of press, and they also do some pretty amazing and interesting things. And these are just three examples. There are many more within Germany and other European countries. Now, one of the problems, of course, is that these companies, when they get really good at what they are doing, tend to be bought up by American investors, right? And this, in some sense, is what happened with Mistral, which, of course, hasn't really been bought up, but, where there has been major investment and therefore major control from outside of Europe. And, while in principle, this is not necessarily a problem, that's just the way the global economy works, right? It is a problem if you believe that some of the directions we're trying to set in Europe, and here's where Kern, formerly known as Clear, comes into play, are important and valuable, not just for Europe, but worldwide, those then basically get squeezed out, right? Because guess what? As soon as OpenAI or Microsoft has a big stake in a company, they also want to set the direction. That's very natural, right? We can't blame them for that. That's, of course, they believe they know what's good for business and maybe also for humanity, and then they go for that, right? But that isn't exactly then leading to a diverse ecosystem where different kinds of ideas have a chance of thriving, right? And so I think what's really important is that in Europe, we create an ecosystem where companies, all the way from inception of an idea through the startup phase, through the scale up phase, can become big enough that they have viable and sustainable global impact, right, with AI products, services, and developments. And that requires sort of a setup where there is a little bit more European investment, although that's not necessarily the problem, but much more importantly, there are European markets where these solutions have a natural edge. And I think we're currently moving towards that. And that's partly a result of the work that we've been doing at this organization that used to be called Claire, until some big American company claimed the name and forced us to change into Cairn, which we also like very much. So, I believe that in Europe we are on a good trajectory there, and it's going to be very interesting to see how countries such as India, Canada, other Commonwealth countries or former Commonwealth countries in particular that are quite highly developed, that have quite a bit of economic power, and most importantly, have a ton of talent, right? That, of course, is very important for making progress across the diverse field of AI. How countries like those will position themselves, right? Will they fall in with the US and chase down this pretty narrow road towards something that might not be achievable and might not be desirable? Or will they branch out and pursue different goals, such as, for example, here is a goal that I think would be super worthwhile. Make something that's at least as good as GPT-5, but uses a fraction of the energy of the training data of the training time, right? That would be a brilliant thing to do. And we know that the Chinese, for example, are working on it. And I say, good for them, but not only good for them, it's good for all of us, right? Because if we have that kind of technology, at a smaller cost in terms of the energy footprint, in terms of who can actually afford to train these models, it's going to be good for all of us, right? Beyond that, of course, there are different kinds of AI that we should be pursuing. We've already talked about that. I mentioned Celonis. That is a great example for such a flavor of AI called process mining. And we should really make sure to not bet everything onto this one direction that currently is so hyped up. I mean, that direction is interesting and should be probably further pursued by those who believe in it and are good at it. But we really need to make sure that other ideas are pursued as well. Because, and here's an interesting lesson from history, the technology we currently have in AI that is so hyped up is based on neural networks, right? You know this, and most of your audience has probably heard about that. Um, Neural networks were a big thing in the 1950s and 60s and through part of the 70s. And then actually, they became very much shunned. People very much stopped believing that neural networks would be a fruitful direction to pursue. And those people have been completely wrong, as we've seen now, right? This has happened in AI, not just with neural networks, but also with other kinds of technologies. And there's no reason to believe that LLMs and the technologies underlying them are sort of the last word, right? So in other words, I'm sure there are other technologies, I don't know which ones yet, that will become very important in the future in AI. And it's very important that we create and nourish an ecosystem in which people that do research in these directions actually have the resources to do that. And that's what we're trying to do in Europe with organizations such as CAREN, formerly known as CLARE.
You spoke about, shrinkage of the workforce. That doesn't seem to be the problem in US or China, because China is like a state-sponsored AI and lots of money. In US, obviously, they're building in at breakneck speed. What's the approach that European AI is taking with, talent shortage specifically? I mean, in the space where, like, the Metas and all, who are, like, pumping in tens and hundreds of millions of dollars to acquire these talent, and for the brilliant young students entering the field of AI today, what is that one area you believe is currently underhyped but will be critically important in the next decade?
First of all, how do you deal with this talent issue? In some sense, I think this is currently resolving itself a little bit, right? I mean, the political conditions in the US, without going into any detail, are such that many young researchers don't feel that they have a good future there any longer. Even though in industry, of course, conditions are still very good, right? So I think we are increasingly driving towards a state where, a lot of people who aren't originally from the States, for good reasons went there because they found a society more willing to take risks than most European societies, more resources and so on. Many of them are currently seriously thinking about returning, and not only to Europe, but also to places like Canada and so on, right? So I think this is a development that is very unfortunate for the US, but that might be advantageous globally, because I really believe that it's good if AI progress is driven not primarily by one or two countries. It should be driven by many players, by sort of a broad ecosystem, right? The other factor I think that we see at play, of course, is that the US-based companies, they are chasing down this narrow road, and there are increasingly many young people who don't want to be on that road, regardless of what kind of salary you offer to them. And the reason is twofold. The first is they deeply don't believe in the scaling hypothesis, and that, doing this kind of work really will make a difference in the end, right? I think there's an increasing number of young people who feel that way, and that's very reassuring. And secondly, because although some of these companies originally waved a big flag saying, let's not be bad, let's be good. In reality, what they're doing is not necessarily saving the planet, right? And it's not focused on that either. And that's fair, right? Not every company has to try and save the planet, but young people in particular, they tend to be idealistic, and this is good. And many of them want to do something that helps us better our situation, do something good for the environment and so on. And these big companies, I think, are not good environments to do that kind of work for the major part, right? And that also helps with retaining talent and attracting talent to places like Europe. I think what Europe should do, I think steps and discussions are in the way. Europe should have something like a CERN for AI, right? I mean, of course, many of us have heard what CERN is. It's an exciting place for physicists, young and more senior, to do sort of groundbreaking work, not just in particle physics, but also in other areas. I mean, the World Wide Web has been invented there literally and rolled out from there. So having something like a CERN for AI, a big publicly funded institution that attracts talent from all over the world, and then of course also gives back that talent when they've done projects there, has that talent returned to places like India, Canada, also the US and China and so on. I think that would be marvelous to have. And my hope is very much that in Europe we might be able to set something like that up. We are currently in the process of setting up AI factories and soon AI gigafactories that try to address this issue. How do we responsibly transfer AI technology into industry and help industry do the right thing economically as well as societally? I think that's a very promising direction as well. Your second question was about the one piece of advice that one could give, young students or young people in general that are maybe enthusiastic about AI, but don't really quite know yet what to do. And here my advice is actually quite simple. Don't just run where everybody else is running with your talent, right? Don't think that just because currently all the action seems to be, at OpenAI, at places like that, and focus very narrowly on scaling up transformer models and things like that, building the next version of GPT and so on. Don't run with that, because first of all, if you do that, you will be one of many, many, many chasing after the same goal. And even if you believe that goal is worth reaching, I think you can have more impact by doing something slightly different. I think most people who really had impact in the history of humanity did something slightly different, sometimes radically different from what everybody else thought they should be doing. And young people are good at that. So I would say, run with your ideas, run with your talent, explore. And the one area that I currently think is thoroughly underexplored is the area of, AI reasoning, and in particular, the integration of natural language interaction with AI reasoning systems. What many people don't know is that we wouldn't have any of the AI technology, and actually none of the information technology, including the technology, Eddie, you and I are currently using to record this podcast, if it weren't for AI techniques from the area of automated reasoning. And why is that? It's not that the studio software is doing automated reasoning, but the hardware on which all of this runs has been run through automated reasoning systems to make sure that the hardware is working correctly and efficiently. And that has been happening for the last 20, 30 years as hardware complexity reached a level where human engineers, even very good teams of engineers, could not assure these properties manually any longer. So they are using AI reasoning systems in order to make sure that all these chips do exactly what they're supposed to do and nothing else, right? And so that is an incredible success story for AI that very few people know about. But it's exactly an example of AI reasoning, which is really important for all sorts of scientific applications as well. Now, getting better access to AI reasoning systems, good AI reasoning systems through natural language interfaces is a formidable challenge that I think will require a lot of talent to solve in a satisfactory way. But whoever solves that, I think will help us make a major step forward towards the kind of AI systems that we should be building. And those are safe AI systems, sustainable AI systems, and AI systems that work correctly as we intend them to work and don't give us bad surprises.
Right, Professor, my last question to you. What's the moonshot? What comes next for you? And you are a champion for democratizing AI, decentralized AI, human-centered AI. Will be great if you could leave our audience with your vision of the world in the next 10 years and beyond.
Yeah, so my vision of the world in the next 10 years and beyond is that we focus really on building AI systems whose strengths and limitations we understand a lot better than the ones that we currently have, right? And then I think we ought to use these systems with a focus on global problems, on solving global problems better. And this includes, better healthcare, including preventative healthcare, right? You talked earlier about the importance of, making progress on curing diseases. I think even more important is to make progress on helping people avoid diseases in the first place. And I'm sure there is a lot that we can do as we understand better how not only how our bodies work, but also how they interact with the environment that we're all part of. And then, of course, taking better care of the environment that sustains us here, right? I think it's ludicrous to want to become a multiplanetary species, as some of the tech leaders say, without first realizing that, in the known universe, currently there's only one place where humans can thrive, and this is right here. And we're messing it up. We should stop messing it up. We should use all the technology and all the talent that we have in order to not only do less damage, but to repair some of the damage that we've already done and find a better way to live in synchrony and harmony with this environment. And I think AI can be used towards this purpose, right? So I think my hope is that within the next 10 years, we will focus a little bit more on safe and secure and sustainable AI systems that we can rely on, whose strengths and weaknesses we know well enough that we can responsibly use them in order to run our societies in a better way, to better interact with and take care of our environment, and also to better interact with each other, right? I mean, we shouldn't forget we live in a world where there is a lot of armed conflict and a lot of unfair distribution of resources, all of which in principle one should be able to resolve because, the planet can actually sustain the number of people that live on there without fighting for resources. We just have to figure it out, right? And that's an important thing. And I think maybe AI systems can ultimately, used in the correct way and used in the context of, bigger efforts, can help us be a little bit more rational about some of the choices that we make. Because I think many of these problems, the unfair distribution of resources and so on, comes from human failure, right? Not that we want to mess things up. It's because we mess things up because we're too short-sighted, we're too greedy, we don't understand the consequences of our action, and we don't understand how, without sacrificing much at all, we can do better. And I think we should really focus on AI systems that can help us with these things. And I think there's a very good chance that within the next 10 years, we can make major progress towards that end. And that, I think, would be truly wonderful.
Thank you for leaving us with such a profound note, Professor. Yes, I think we can definitely do better. And you spoke about, the world today. There's so many armed conflicts. And if AI can resolve that, and bring, maybe make the world more equitable, I think it would be such a beautiful thing. Thank you for taking time and being part of the podcast. It was a extremely insightful conversation. And to my listeners, if you like what you see in here, then please press the subscribe button. Until next time, see you guys. Bye bye. Thank you. Thank you, Professor. Really, really appreciate this. Yeah. Thank you. Thank you.
Entirely my pleasure. That was a stimulating conversation for me as well. Thank you.